How can I easily understand different number-based systems? Imagine trying to read a language you've never seen before. That's what understanding different number-based systems can feel like at first. But don't worry, it's easier than it sounds. Think of a base as the number of symbols or digits used to count. For example, in the decimal system, which we use every day, there are 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. When you reach 9, you add a new digit place and start over at 10. Now in the binary system, which computers use, there are only 2 digits, 0 and 1. Counting in binary goes 0, 1, then 10, which equals 2 in decimal. After that, it's 11, which is 3 in decimal, then 100, which is 4, and so on. Each position in a number tells you how many of that power of the base you have. For decimal, the rightmost digit is worth ones, the next is tens, then hundreds, and so forth. In binary, the rightmost digit is worth ones, then twos, fours, eights, and so on. To get comfortable with different bases, try counting in them. For example, in octal, which has 8 digits from 0 to 7, counting goes 0, 1, 2, 3, 4, 5, 6, 7, then 10, which is 8 in decimal. In hexadecimal, which uses 16 symbols from 0 to 9 and then A to F 4, 10 to 15, counting goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, and 15. After that, it's 1, 0, 1, 1, and so on. Converting between bases is like translating languages. First, break the number down into its positional values in the original base. Multiply each digit by its power of the base and add everything up to get the decimal equivalent. To switch back to the new base, divide the decimal number by the new base repeatedly, noting the remainders. These remainders from the digits of the new number, starting from the last one you get. Different bases have practical uses. Humans tend to use decimal because we have 10 fingers. Computers relying on binary because electronic circuits have 2 states, on and off. Octal and hexadecimal are used in programming because they make binary numbers easier to read and write. For example, a byte in computer memory is often shown as 2 hexadecimal digits, which is much simpler than a long string of zeros and ones. Number bases also have roots in history and culture. The 12-base system influenced how we measure time and distance, like hours on a clock or inches in a foot. The sexagesimal system, which is based on 60, was used by ancient civilizations for astronomy and timekeeping. This system is why we have 60 seconds in a minute and 60 minutes in an hour. Understanding that a base is just the count of symbols used to representing numbers helps you see how different cultures and technologies develop their own ways to count. Visualizing counting sequences and practicing conversions makes the idea clearer. Remember, each number system is just a different way of organizing and expressing quantities, reflecting how humans have historically approached counting and measurement.